Number 44, integral of 1 plus e to the x under the square root times dx. What do we do here? Integration by parts? Might be doable. Let's come back to that. It's not a trig integral, not a trig sub, not partial fraction decomposition. Can we do a normal substitution? I don't see something obvious either. So it's kind of like the one that we just did if you came from the previous problem. We have to either resort to trying a substitution or we resort to trying integration by parts. What do you want to do? Maybe let's try a substitution. I don't know if this is the best way, but let me try. If I can avoid integration by parts, might be helpful, okay? So let's let u be, well, I don't see any benefit to letting u be 1 plus e to the x, okay? So why don't I let, because du would be e to x dx, there's no sign of it there. So what if I let u be 1 plus e to the x under the square root? Maybe that will change things up a little bit. U squared is 1 plus e to the x. So then 2u du is e to the x dx. Okay. So we can also write this as 2u du is e to the x from this line right here is u squared minus 1. Okay? So we have u, and then dx is 2u du over u squared minus 1. So we have 2 integral of u squared over u squared minus 1 du. Okay? So how do we solve this? Maybe integration by parts would have been better if it's doable. We got to do a partial fraction decomposition a bit. Okay. Sorry, I still need that definition. U is square root of 1 plus e to the x. I need that to back substitute in the end. Okay. This is me solving the slide. Again, if you have a more efficient way, please feel free to share in the comments so that other people can learn. But you can see how I'm thinking through the problems with just standard techniques. Okay. We can do that half where we do this. U squared minus 1 plus 1. I'm not changing anything on the top. So this becomes 2 integral of 1 plus 1 over u squared minus 1. Okay? And I keep erasing that, but I need it. Let me write it up here. U is square root of 1 plus e to the x. Okay? So if I do partial fraction decomposition, it'll be a over u plus 1 plus b over u minus 1. By the way, I don't know if I said this before in some other video, but if you're an electrical engineer, you might need to do partial fraction decomposition quickly in some future signals classes. That's how I learned to do some of these quickly, but it's been a while though. When you have a difference of two squares, the a and b are usually kind of symmetrical. They're the same number, maybe different by a sign a lot of the times, okay? So let me just work it out. Okay, I kind of don't want to, but all right. U minus 1 plus b u. I keep hitting erase, but okay. So if we let u be 1, then we get b would be half. If we let u be negative 1, we get a is negative half. As I was saying, they should be kind of symmetrical, maybe different by a sign. Okay? So there's that. And now we can write this as 2 integral of 1 minus half times 1 over u plus 1 plus half times 1 over u minus 1 du. Let me erase all this, start integrating it. All right, so I'm going to go up here now. We get 2 times u minus half ln of u plus 1 plus half ln of u minus 1. Those are F's values, by the way, plus c. And then we got to back substitute this mess. We can distribute that 2 as well. 2 square root of 1 plus e to the x. minus ln of square root of 1 plus e to the x plus 1 plus ln of square root of 1 plus e to the x minus 1 plus c. Let me double check this is what I got previously. Yep. Oh, this is exactly how I did it as well. Okay, cool. That's our answer. Hopefully, this was helpful to see how I'm thinking through this. And hopefully, another key takeaway is, again, the partial fraction decomposition I was talking about.